So at this point in the year, after we have covered test and confidence intervals, compared one sample to two sample, worked with means with a t-distribution, proportions with a z-distribution, we are at the point now where we have so many procedures under our belt that whenever we are working with one of our questions dealing with inference procedures, the first thing we have to figure out is which one we're working through. And so this is something I always like to do. So a couple of questions or maybe hints, if you want to think of them that way, and each of these sort of in separate parts. So tests versus confidence intervals. The purpose of a test is to, again, assess a claim. So whenever we are assessing a claim, we are being asked, do we have convincing evidence of something? Is there a difference between these two to find the null and alternative hypothesis to answer that particular question? So we're assessing a claim, whereas the purpose of a confidence interval is for an estimate, which I already have written right here. So to provide an estimate. So and now we sometimes want to quantify, like how much of a difference is there? How many do we see between these two groups? So that helps us to provide an estimate. So that's the first part. The second part, again, and I feel like this is one of the more obvious ones, is it one sample or two sample? And so we won't see it all in the problems that we do today, but when we're working through some of our other practice problems or AP released questions, one sample, there's only one sample size that we should have to worry about. So just by nature of the given information, you have far less. Whereas with two sample, we should have two independent samples. And then the new one that we've added to the mix is matched pairs. This is sometimes presented where it could easily look like two sample. Sometimes we are given all the raw data. So we are given like the pre-test and the post-test, the before and the after, whatever it might be, and then the list of differences. So we see three different lists essentially. Sometimes we're just given the before and after, and we have to find the list of differences on our own. Sometimes we're just given the list of differences. And so this one's a little bit harder to distinguish, but remembering that we typically have two measurements on each individual, that there's some way to pair them together, like the AP question where you try the medication or ointment on the left arm and on the right arm of the same person, as opposed to two different groups of people. And then finally, we're dealing with means versus proportion. So again, trying to think of what the most obvious thing would be. When we're working with means, we have to know something about standard deviation. And so same thing, if we're given sample size and given standard deviation, it should lean us towards means. For proportions, I think the trip up is that it's usually given to us as a percentage and it's not written as a decimal point. Or they sometimes give us the count of successes and then give us the total, because you still need to see the sample size when you're working with proportions. Even though when actually we get into the formula component of it, we need to write it as a decimal point. So at this stage of the video, I want you to pause me and take a look at this worksheet, the name the procedure. So trying to be as specific as possible. So is it one or is it two sample? Is it T for means? Is it Z for proportions? And is it a test or a confidence interval? So really a lot of components there. You might get some of them right. And typically, if we have errors on this, we tend to do the same thing over and over again that's incorrect. So there's one easy switch, like people will accidentally switch means with proportions, that sort of thing. Come back and I will explain why the right answers are the right answers after you've had a chance to work through these 13 on your own. Okay, so if you checked answers and got them right, that's awesome. No need to work or listen through the rest of this video, but if not, to try to figure them out. Some of them should have been super obvious. Some of them, like the first one I thought, were maybe a little bit tricky. Do men spend a higher percent of their free time outdoors than women? Questioning men and women. So this is a two sample. I think that's easy to see. And do they? Kind of yes or no. This is going to end up being a test. But maybe what was a little bit tricky about this is that you saw the word percent. And that's just how it's being measured. But if you're asking individuals what percent of their free time Did they spend outdoors 50%, 70%, 80%? And then finding on average what that would be to compare the two, it would end up being a t-test. It wasn't, is the true proportion 50%, sort of thing. So first one off to a little trick already. Number two, we're estimating. And we have just one set of students, 92 of them. It even says average here for us. So this is going to be a one sample Z confidence interval. For 3, are coffee drinkers more stressed out than those are not? Because we know the stress level was on a 100-point scale. Coffee versus non-coffee drinkers. Again, so I obviously have 2 different groups. Knowing that scale, I can... sorry, I realized I wrote a Z up there. I can find the average stress level for them. And we're just asking, are they more stressed than the other? Kind of like a yes or no. Not how much are they stressed. Now, a lot of these tests we saw, we can use a confidence interval to answer that particular question. But this just based on if our default is estimating versus answering the question, we estimate with confidence intervals, we answer with the tests. Number 4, is the average down payment greater than 10%? So this, again, you could figure out what 10% of their first home is. Asking 300 first-time buyers, is this average greater than or not? So this would be a one sample t-test, since we're dealing with just those 300. Number 5 should have been really straightforward. What proportion cause serious injury? So they either do or they do not, if that's the way that the accidents are classified. So this would be a one prop Z, and it's asking what proportion. So even though it doesn't say estimate, I'm trying to quantify the proportion that caused the accident. So that's what makes this a confidence interval. Messy dogs or cats, how many pieces were next to each one? So trying to find on average how much food is left over. Our dog Layla was famous for this. Dogs versus cats. So we have 2 groups here. We're looking at how many, so we're quantifying that with T. The question, though, is just asking, are they messier one or the other, which is why we go for a test on this one. Restaurant, how much is consumed on an average day? And so we're looking at the one particular restaurant, and we're trying to answer the question, how much there is being used. And so this would be a 1 T confidence interval. So again, this is just my shorthand, but a 1 sample T confidence interval for that. You have to do much better than that in the state step, identifying which one is which. So number 8, are the eggs more likely to successfully hatch? So this again was sort of like, is it a serious accident or not? Do they successfully hatch or do they not? Obviously 2 separate groups. And do they or do they not would make that categorical. So it would be Z. And then just, are they more likely or not? Not how much more likely, which is why we use this one as a test. Do more than that particular percentage stay free from ovarian cancer? So we're dealing with one group of women here, and this is a Z test. That really is just setting up the hypotheses for us by giving us that particular value. Maybe none of the other questions actually gave us that particular number. Like I had set up above, this is really a scaled down version. You need more information than what is given to answer all of these questions. But just to kind of get the gist of it, is a man who walks into a car dealership more likely to purchase? So this, again, they either do purchase or they do not purchase an automobile. Men versus women, so it's obviously 2 sample. And then Z, because again, the proportion is they either do or they do not. The last couple, finally we can get to some confidence intervals here. It feels like there have been a fair number of tests. Estimating the average number of texts being sent, we have one group of college students. So this is a 1 sample T confidence interval to estimate that true average. So 12 may be a little tricky. What is the average voter turnout during an election? So this again is always reported as a proportion. But then if we're taking those proportions and trying to work through what we might consider an average to be, this really thinking averages, we would think of it as a T confidence interval. But again, not something we would normally do, taking the average of the percent. The last one, how much does a speed reading course help? And so here is a perfect example of before versus after. So we take the assessment, whatever it may be, to see how well, how quickly, how much we can read in a certain period of time. Take the speed reading course, take the testing and after, and see how much of a difference there is for these particular students. And so since we're being asked how much does it help, this would be a matched pairs T confidence interval. So again, to assess this one, we wouldn't actually work with the before and the after. We would find the difference for likely after minus before to see if there is an improvement. And that one particular list we would analyze just as if it were a one sample T confidence interval. It's just a matter of how we are referring to the data because it's the list of differences, not a list of raw scores.